All right, good morning, everyone. Welcome to our weekly storage API sync, where we talk about the backend storage for Subspace Network, this distributed storage. Today, we're going to be mainly talking about the relayer and the Kusama archiving process and backing that up from Genesis. Serge, we'll go ahead and let you start off and update us from the last call.
Cool, thanks. So I think we go as usual with PRs first, and then check our priorities. So since last we spoke, I had like 4 PRs merged, and this one is pretty simple. As discussed, now we crash the whole application relayer backend in case transaction is too big. So previously we were just skipping the block and transaction if it's too big. So currently we use this command process exit, and it will crash everything. Yeah, quite minor. I assume no questions about this one, right? Okay. The next one was so before this one we were submitting blocks in different format because we were getting them in from different sources, and blocks we were processing from archive we were storing as bytes in the RocksDB, and we were submitting as hex string to the subspace, while blocks we got from the RPC API over the network, we were submitting as stringified JSONs, simply because without custom types, it would take some extra work to convert them to bytes or to hex. But not anymore. Now we can submit all blocks in the same format. So this PR was focused on the blocks that we are getting from the RPC API, both like Polka.js WebSocket API and blocks we are fetching over HTTP API parablocks specifically. So I was reusing some methods that Nazar already implemented in this script that we use for downloading substrate blocks. There were a few interfaces. They look similar to Polka.js, but they are not exactly the same because we have like strings instead of like specific types. So this is what we get over the RPC, and so I moved it from this script file to separate module over here to our backend types. So here they are, and I moved the methods to convert blocks to binary and to hex, some utility functions to our relayer utils. And I also added this function to check if the object is an instance of this signed block type we get over the JSON RPC. And then I just use it for converting parablocks over here. So we're using the JSON block to hex helper function. And for Kusama blocks, we don't need to use this one because we get it from the Polka.js API, and it has this method that will instantly convert it to hex. And I tested this function on the Kusama blocks. So both this method and this function, they produce same result. Yeah, it's just we only apply it to parablocks to avoid using custom types. yeah, this is basically it. Any questions on this one?
No, makes sense to me.
Okay. So this and this. Okay, so the next PR was process blocks from archive. In this case, Kusama blocks. And yeah, so we created a new class. It's called chain archive. Nazar created and I have extended it. And basically what it does, we have a method to get blocks from the database, from the RocksDB by number. And we also we have this method, which is the main public method, get blocks, which returns async generator. Initially, I tried RxJS to have it consistent with source class, but eventually it was easier to implement using async generators. And at some point, I will convert source class methods to use async generators as well. So yeah, what it does, we get the last block from the database. So in the database folder, we have a text file with last block number. So we get this value. And from our local relayer state, we get the last process block number. And yeah, we have a loop while the last process block number is larger or equal, less or equal to last process block number in the database. We fetch blocks from the database and we yield these data objects for transactions if payload is within size. So we're using the same method we use for the source, which we'll update later to be consistent with the check on the protocol level. And yeah, I also added interface into our config for archives. And previously we had the configuration data all in the configuration class module, and I removed it from the module, and now we have it in a separate JSON files. So this is JSON for archives, where we specify the endpoint for the API. Currently we use it, but later I removed WebSocket endpoint for parablocks and replaced it with HTTP endpoints for both parablocks and Kusama. And yeah, we have to specify the path to the actual database instance. And I also extracted source chains we use to fetch blocks over the networks into separate JSON file. So this one is pretty straightforward. And yeah, this is how we use this new class. So basically, I created, we provide a new parameter when we run the application archive, and we check arguments. If this parameter is provided, then instead of creating instances source class, we create instances of chain archive, and we basically provide almost the same inputs. And then we have this array of archives, and for each one, we call this get blocks method I mentioned earlier, which returns a async generator, and we can use for await loop. And for every item, we submit transaction. And in order to avoid extra requests for the nonce every time we process the item, we send transaction, we do it only once, and then we increment the nonce value manually. So every time we send transaction, we just add one to the nonce. And we still have our default mode for processing blocks over the network. And yeah, few updates, minor updates here. Just specify the public private explicitly for some of the methods. And yeah, this is a new method. I just extracted some logic here. And yeah, and for the send block method for the target, we have a optional parameter nonce. So we can explicitly specify it. And that's it. Any questions on this one? Okay.
Okay.
Can you hear
That's
me?
everything, Serge? Yes, we can hear you.
No. And one more. Oh, I have one more. So this was Kusama blocks. And the last one was parablocks. And yeah, so first I have updated the README because the README was a little bit outdated. So yeah, we don't store source chain URL because we have multiple source chains. And I describe it in the README that if you want to process blocks from over the network, then you use source chains JSON. Otherwise, you use archives JSON. And yeah, I provide an example of this configuration file because for every user, this path will be different. And I have added some additional scripts. And yeah, there was a few like optimizations for the chain archive class. Previously, we were using the API, and we can't do it for parablocks because otherwise we need custom types. So instead of passing the API itself, we just use type registry from Polkadot package to create types. In this case, we create a hash type because remember we were discussing that instead of fetching block hash over the network, we do it locally. So we apply Blake algorithm to the header and we get the hash locally, and this gave us some performance improvement. And yeah, there was a hard-coded chain name for every parachain in the config, and I replaced it with HTTP request. And I collected all the HTTP request methods into a single module. And yeah, there is still some work to do here, like a lot of code repetition that can be improved, but yeah, we will do it in the future. So now we can use this get chain name method to get the chain name for Kusama and for parachains. So for the archive, we use it in the index file right here. And we use it for parachains in the get, in the, what was the name of this? The method create parachains map method. Yeah, when we create parachain, we provide the parachain name. Yeah, that's it. Any questions on this one?
Not from my end.
Okay, and yeah, so previously, like yesterday, I was testing backing up Kusama on the environment, and Leo helped me to deploy everything, and we ran into few issues I mentioned, and today I created issues on GitHub so we can keep track. And yeah, one was related to JavaScript heap out of memory, and yeah, also Nazar had similar issue, and I created another one for the.
Hold on, let's discuss that one before we move on to the next one.
Sure.
What's the status on that, or who's that assigned to right now?
I assigned to myself, but
Okay.
I haven't started to work on this yet. I thought we should discuss it on this meeting and prioritize, because.
Okay,
Yeah.
let's discuss it. What do we think's going on?
I think it's the same thing that I described in the engineering chat in Discord. It's basically a runaway problem. The relayer tries to do as many things as it can as soon as it can, and basically runs out of memory. So what needs to happen, it needs to track how many in-flight blocks it tries to relay, and basically have a cap on that. Let's say no more than 500 blocks at the same time. As one is finished, it should start the next one, but not more than 500 concurrently. Then there will be some bound on the memory usage. Otherwise, it can just produce blocks, a lot of blocks, which results in two problems. The first problem, it can overload the transaction pool on the node side, and just some transactions will go out of transaction pool because of that and will not be archived at all. The other thing, it can actually submit so many transactions that node can handle it, but the amount of data and subscriptions that the application has to keep track of will be more than the heap size, so it will run out of memory. So both of those things will be fixed if we have the limit on how many transactions are processed concurrently. I think this is what happens.
Does it make sense, Serge?
Yeah, more or less.
Okay, so it sounds like we need some kind of like a mempool on the relayer that has like a max size, like of pending transactions or pending blocks.
Not a mempool. We basically need to, like, every time we call send block, we need to check if we can send it. If not, we can basically wait. So the whole like archiving process will pause for a little bit until there is more space to process, like more capacity. So basically we need to have some kind of check and delay that process.
Send block or read block?
Send block, because we are we are reading the block and then we are sending, we are reading and sending, reading and sending. So if sending is paused, then the reading will not happen either. It's like a loop.
So we should have like a max unsent count, or no? I guess I'm just trying to get some definition on this so that Serge has a clear idea what to do, how to implement this.
Yeah, I think I can start, and if I have any questions, I will clarify with Nazar.
Well, what are you thinking, Serge, for an implementation?
Currently, I'm thinking, how do we? So we have issues on GitHub, and we have tickets in Notion. I'm thinking about that part more at the moment. How do we have the whole picture together? Do we have to create a Notion task for this, or we just have tasks in two sources?
I think we need to just move tasks to GitHub over time.
Or we move everything to GitHub?
I don't care. However you want to manage it. That's, I mean, what matters is just that we build it and get it working. So that's really up to you, Serge. But what I'm more curious about is, what are you thinking for an implementation of fixing this bug?
I need more time to think about this.
Okay. Well, I would like to define something right now, so that, because this is like the next issue that we need to, it sounds like we're not going to have anything working until we sort this out, because it's always going to have a memory.
Okay, roughly how it should work. Basically, we have a function that sends a block as transaction. And in that one, we have a subscription that the transaction actually went through. And we were printing a message and still printing the message in debug mode. However, we did not wait for it to finish. So basically what we need to do, we need to wrap that function in a promise and resolve that promise only when subscription return that the transaction is actually included. So we can call that function and wait if we need to. And then we will basically chain all of those things somehow into sequence, for instance. That's the easier problem. Or yeah, basically that's what we need to do. We need to send them sequentially. So we basically make a sequence, but we also make a limit on how long this sequence can be unconfirmed. And if it reaches the length, we basically wait for at least one to be processed. So we'll have like a queue of a specific size. And if that queue is 500, that we will have 500 in-flight transaction waiting before we can put another one into the queue.
Yeah, we're doing this for other methods in the target class. For like create feed, for example, we wait until we have like a transaction confirmed and event with feed ID, and then we resolve the promise with feed ID value. So yeah, that's relatively easy, but this will significantly slow us down.
Not necessarily. We don't need to wait for them one by one. What I'm saying is that we should be able to send 1, 2, 3, 4, 5 until we have 500. Then we will wait.
Yeah,
but
like
by the time, hopefully, the first one is already finished, so we'll be able to like continue doing this. But if it's not finished, then we'll just wait and not run out of memory.
And whatever 500 is, that should be really like twice the number of transactions that we think we can fit in a block, or else we'll get to this point where we fill up blocks and then we kind of have this period where we're waiting to fill up blocks. So we should always have like an over full mempool in case we mount a block
depend on
immediately
the
after.
size of the mempool.
Yeah. Yeah.
Because I was able to overflow the mempool locally with latest updates.
Okay.
And I had blocks like 1600 transactions in them.
Are we using default mempool size from Substrate?
I think so.
Maybe we can increase it.
I will talk about that later.
You're going to cover that, Nazar?
There are some nuances.
Okay. Okay. Serge, can you create a ticket for that? And regarding the GitHub Notion, we can let's keep everything in Notion for now. As soon as we get a version 1 working, we'll migrate to GitHub. Okay, but I don't want to have like parallel boards in the meantime.
That was something I wanted to clarify. So okay, we keep the GitHub issue, but we also I work on Notion ticket, right? But we have GitHub issue just for public awareness.
Yeah, that's more for like bugs or things that we want to tie PRs back to, but not necessarily for just for project management right now.
So update to resolve promise and send transactions as batch. Something like this. I think I will understand what to do. Okay. Anything else on this one?
I think we're good.
Okay, so the next one is, yeah, I have experienced this issue. As you can see on the screenshot, we have like block 2, 3, 4, 5, and then this is like screenshot from recent events section on Polkadot apps. So there were blocks starting from 6 to 9 that didn't have any transaction, any events included. And then we had blocks 10, 11, and we again have this gap, few blocks without transactions. So I think those might be related to like transaction pool, but yeah, I just created it just in case if it's a different one.
It can be a transaction pool. It can more likely be the relayer itself if it was a few days ago. And it's still likely to be the case because some of the modifications that I did, they're only on my local modified branch. Not even a branch, like I modified files under nodes modules to test some of the upcoming changes. Basically, when we have a lot of transactions, there is a lot of events and transactions when the relayer tries to get a block to analyze it and resolve your subscription for a particular transaction. So it needs to know that this transaction was included and this is like the events and stuff that are related to it. And unsurprisingly, that takes time. So when you have 500 of those, it takes quite a bit of time to actually process all that stuff. And that is a single-threaded operation on the Node.js side. And then it needs to clean up the garbage that was produced in the process. So sometimes it can just be the case that it just takes time on the Node.js side. That it is not able to do anything else while that happens.
Okay, so for this one, we can wait for your changes to be applied on main.
Yes, I see the same. I saw the same behavior, but I see it much less recently. So I think it might be going away soon.
Okay, so we keep it on hold for now, right? Is it okay
Yeah.
for you, Jeremiah?
Yeah, just make a note in the issue about what Nazar said, and hopefully we can just resolve it. It'll just, yeah, like we said. Okay. Any other issues, Serge?
Yeah, and another one I created the issue I had, the error I had on the farmer side. Yeah, but we discussed it previously with Nazar, and he said it's not actually farmer. But yeah, I had it on the farmer, and after that the block production stops. So yeah, this is another issue I created.
Okay. So it's not on the farmer, then what is the issue?
Can you comment, Nazar?
There are interesting different side effects of sending large amounts of transactions and including them into the same block on substrate side. And at some point, it basically stops block production. I have some ideas why that might happen, but I didn't find the fix that I can like reproduce the problem, try to apply the fix, and confirm that the fix helped. I don't have that sickness yet figured out.
So this is some side effect of an overloaded mempool or just like a strained node. We're hitting like performance issues within substrate or weird side effects.
I'll probably talk and then go to my part. And there is also one
Okay.
more thing which I think is related to the layer. I was having these issues when there was a lot of transactions. There are several similar tickets in other projects, and I think this is something we'll have to figure out eventually as well. I thought it was related to block production stall, but it seems to be for a layer.
I think it's not related to too many transactions in the pool, because this happened second time when I was processing blocks over the network. So we had like 5-6 transactions per block, which is not the same as we have from archive.
Well, basically
So
something is going wrong and that transaction is not included because of that. So we need to figure out how and why and how to fix it.
Okay. So you've got another issue in in the monorepo to track this already, Nazar?
It's there for now. We might transfer it to the other layer.
Okay.
Yeah, that's it. And currently I'm working on the transition from processing blocks from archive to real-time processing from over the network once we are done with archive. And one thing I also would like to discuss, because currently we are debugging a lot of stuff like on the deployed environment, but we are not storing our logs into text files. So we, like, in order to understand what's going on, you have to keep track on the console and read logs. And there is no way you can just read logs that were already like disappeared. So I think we should prioritize that to save logs as text files so we can analyze later, and maybe update what we store in the logs as well.
I would say we instead should build a container and let Datadog handle it.
Yeah.
Okay. What's stopping us from doing that right now?
I think Leo already tried Datadog, right? He mentioned yesterday.
Yeah, he set up the whole thing, but our layer application is not in a container. It's running under PM2.
Mm-hmm.
Just need to remove PM2 and run it as a container.
Okay. Is that something that Leo can do?
I will create a ticket to create a container for Relayer, right?
Yeah. Can you assign that to Leo, please?
Should I move it to no status? Yeah, I think I'll.
Not started, I guess. That should be the next.
This is
like
higher
high priority.
Yeah. Okay. Yeah, I guess that's it on my side.
Okay. Thanks for the update, Serge. Let's go through Nazar's update so we can get a better picture of what the problems are and where things are at, and then we can talk about next steps. Okay, Nazar?
Hopefully you can see it.
Yeah.
Yeah.
Okay, so there are 3 pull requests. The first one is what Serge has already kind of went through. I implemented the generic method, which allows it to take the information returned from JSON RPC API and basically turn it into the binary. And also I added some utility methods to get things from. No, that was before. This actually changes the WebSocket usage for HTTP usage. It basically fetches blocks from parachains and relay chain the same way as Serge does in the regular live mode. So that allows us to not care about all these types for different networks and the fact that they change over time. That was the first pull request, nothing really special there. Then I did some performance optimizations. Turns out more optimizations were necessary, but this is one step towards it. So I have changed some of the numbers from BN and big number to actually just number, because just number in JavaScript allows you to store up to 54 bits of precision for integers without losing it. Losing precision. And that's fine because all the networks that we care about, they only use 32 bits integers for block number, so that's plenty. You don't need to pay additional cost for that special class. And actually, Polkadot.js is happy to work with just numbers or begins native in JavaScript. I think BN was really mostly relevant for older browsers or environments. That was one optimization. I had to change types across. And the second one was basically we have, where is it? Yeah, so here we were basically getting the block, and then we were trying to interpret it as a header because it starts with a header, such that we can then use that header to turn it into bytes and hash it. So we can get the hash of the block, right? Because that's effectively hash of the header of the block. But I thought that I actually I traced it in the profiler, and I saw that it spends quite a bit of time figuring this out, and we don't really need the parsed header at all. We just need its bytes. So I wrote a simple, relatively simple get header length function, which basically goes through the bytes of the block, and it reads the header size by reading all of the fields and data structure as it is in the Rust implementation. And it basically calculates how big the header is, such that we can quickly slice it and hash it without actually decoding, which also helps a little bit. Those were two big changes here that helped a little bit with the performance. Then I did also some minor tweaks here. The first one was to change the debug output to debug output from the info output for different transactions included. I thought it was very verbose what was printed in the console, but we want to know how quickly we do this thing. So instead, I added the info message, which is printed every how many blocks you want. By default, it's 1,000 blocks. It will basically print you blocks per second performance the console from time to time. So that way you can have a pretty good idea of how quickly it works. Those were the performance changes on our layer side. There were some other pull requests to different projects that I did. One was on Polkadot.js side, and it's under review. So there were things happening in filtering events, which is necessary for subscriptions. When we have an extrinsic and we submitted the extrinsic, we want to receive confirmation, and how we figure out that the confirmation is there or what events belong to that extrinsic, we filter those events. So there was basically a bunch of work done up front. So we were converting all of the extrinsic hashes to actually strings. Then we were doing the same for all of the hashes. And then we were doing this inefficient search in array. And then we were checking the index, whether we found it or not. That was actually unnecessary. So instead, we can go through extrinsics and we can compare unstringified hashes right away. And as soon as we hit the one that we care about, we don't need to hash everything else. So that also saved a little bit of CPU. We'd only need to hash it when we want to print an error or warning to the console. So that was the first optimization. That's all from the profiling results. Then turned out that we actually hash quite a lot, yeah, we basically hash quite a lot because every time you access the field hash on extrinsic, it's not actually there. It's actually taking the whole extrinsic and tries to like concatenate it and hash it on the fly. And that is not a super cheap operation. So what I did here, I basically created a memoized version of it. So we have a hash cache in extrinsic. So every time we call this method, we first check the cache. If it's already there, we just return the pre-computed hash. Otherwise, we will hash it on the fly. And that happens for two different kinds of extrinsics. There is still some discussion going on about that. So that saves us some CPU. Then there were a bunch of different regular expressions that were called a lot, and they were all in this hot functions, and they were basically compiled every time they are called, which is not great. And there is a classic approach to fix that. You basically create regular expressions up front, and then you just use them as pre-compiled. This saves quite a bit of CPU as well in the hot loops. So I changed that. The second one was to actually memorize some of the name transformations. Basically, when we have those types injected into the Polkadot.js API, and we receive something we want to decode, there are many places where it creates fields on the fly on different data structures, and it needs to infer what the field name should be from the data types in Rust. So, for instance, there are places where it creates these fields like is something consensus log or something like that. But there were these things which it was computing on the fly all over and over and over again. But turns out there is a very limited set of those keys that are possible for every particular chain. So what we can do, we can actually have a map where we have a key is an input from Rust, like change generic, long generic, and the result is basically the prepared version of that we care about. So I found 3 places of those cases in the internals of Polkadot API, and that helped to remove quite a bit of CPU usage because we were not doing most of the work at all. And turned out that was actually not the final destination. Actually, this memoization can be applied to sanitization on the even higher level, beyond those regular expressions optimizations. So we can skip quite a bit of work in general because there is this big function, not function file, that has lots of transformations that are applied to like every key that that is processed. We basically don't need to do any of this most of the time. We just compute it once, put it into the map, and if it's there, we can just return it right away. So this saves even more CPU usage. So with these optimizations, I was able to get like 400 plus transactions per second on my machine. But these are still in the review on the Polkadot.js API side. I was exploring some other things. No, this is not one. Closed one. So the other one was on Polkadot.js dev. I basically was digging why it generates some of the inefficient code. Turns out there are some Babel, I don't know how to pronounce it properly, plugins enabled that basically applied polyfills for different features that are already natively supported in JavaScript. It should result in better code because we are not polyfilling those things. But there are still some pull requests in Babel itself that are pending that will, where is it? Here. That is still in progress that will help us to remove some of the work on the Node.js side. Right now, it's still not quite there. Babel thinks that Node.js 12 doesn't support private class fields, but it actually does. So until this is finished and merged, it's not as efficient as it would be. But we've merged some of the things that will be helping. And there was also this library that was doing camel case transformations that I found was also spending in one of the profiles quite a bit of CPU usage. So I applied the classical technique of caching precompiled regular expressions there. Still on the review. I don't know how to call these variables properly because I'm not familiar with the library at all. I'll just call them numerically. And the maintainer is not very happy about that, but here we are. It's not actually that bad after memoization, so it's not a hot loop anymore. Yeah, and the latest one was actually, this is currently a draft because it causes more problems than it helps. It basically works too fast for our node to keep up right now, I think. This is 2-step pull request. The first one was the signing pool implementation. So basically the idea is that in Polkadot.js API, you can actually have signers, like custom implementation of signing things. And that is a, where is it? Oh, that's the different file. Basically, there is this signer interface in the extrinsics that you can implement. And I've created another abstract class, signer with address. I highly recommend to create classes instead of interfaces because this was causing me problems until I have it as an abstract class because it only cares on interfaces about these public fields. It doesn't really care about anything else, and it was compiling when it shouldn't, basically. It's a long story. So I implemented that interface in the signing, in the pool signer. What it basically does, it takes the registry, a seed for key pair, and the size of the pool as a parameter, and it creates a number of workers equal to number of to the size of the pool, and it allows you to sign payload. This is the method that Polkadot.js will call, and there is also a public address method field that is useful in other places, because we were using the like signer kind of thing for both signing and address, because it was a key pair. In this case, it's no longer the case. And basically, every worker is represented by the special file, and that file has a handler for events, so we can send messages to it. So in this case, we post a message that we want this message to be signed. We assign an ID for that request. We have a message itself. We actually not copy the memory. We just move the memory from one thread to another. It will sign the message. It will return this message and the signature and ID in the message event back. We read it. We find the requester, call it corresponding callback. This promise results. We have a signature. And the actual implementation of that is in the assigning worker. This is a relatively small file. Basically, we have assign function similar to the function that is in Polkadot.js API. And we have a subscription for messages. We need to wait for the WASM utilities in the this crypto thingy, this one to be finished, to be ready. So once that's done, we sign the message and we post the message back, again, moving the memory instead of copying it. So this thing is running in a separate thread. So we have default 4 of these threads for every for every parachain and relay chain, and that allows us to free our main Node.js thread from signing these things, which is an expensive operation. And then second commit is basically using that pool signer instead of the utilities we had before. So here, when we were creating the master account just as a key pair that has a sign method on it, instead we are creating the pool signer for every single one of them. And then when we want to send some transaction, we basically send that signer. Let me show you some example of that. I think it's in utilities, probably. No. Maybe in target. Yeah, every time we call some method on the Polkadot.js API that is related to signing, we basically can specify signer, custom signer for this particular case. So our signer now has ability to sign and an address, so we can extract the address from here, and we can send it, set it as a signer for this particular transaction in here, because for different target, for different parachains, we will have different key pairs. So that's why we need to customize it every time. And this will happen on the thread pool. It will basically go round robin across all the workers that we have, and that helps us to break 500 transactions per second. I was actually saw like much more than that, but it's not super consistent. Yeah. So with that, we can theoretically send quite a bit more transactions. However, there are problems. And those problems are, I think I created like 3 tickets. This one was a bit older and probably caused by relayer itself, and will be fixed once we have a limit on concurrent ones. This one is the result of, I think, some prioritization problem. But basically, sometimes we were not able to verify the solution because the Merkle root wasn't in the runtime yet. However, the extrinsic should have the highest priority possible, but it seems like it wasn't the case. Yeah, that was fun. There were actually some prioritization changes in the November update, which is included in here, of Substrate. So I'll just need to debug why it happens. It just not allows us some of the solutions to go through. It's not like breaking the consensus, but it is a big problem because this is what we expect should happen when everything works properly. And the second one was more interesting. I think what is happening, and again, this is a new flag available in November update for specifying the custom buffer capacity. Basically, we have blocks which are so big that after serialization to JSON, we overflow the size of the WebSocket output message buffer. So the single message is so big it doesn't fit, and we cannot send it through JSON RPC. And if we cannot send it, that our farmer cannot read it, so it cannot plot it, and it actually breaks the connection. It forces the farmer to restart. because the whole WebSocket thing breaks. So it basically causes crash loop on the farmer side, and it actually causes more problems on the sender side if you don't specify this
Sorry.
parameter.
Sorry, Nazar, you lost me there for a second. So I just want to make sure I'm following you. So Relayer is sending transactions to the Substrate client. The Substrate client's putting them in the mempool. They then eventually get archived and sent over to the farmer. But the archive segments are so large that they're
Not segments.
Not
No, segments are fine. It's about blocks. Like one of the blocks can be up to 5 megabytes. If you add hex encoding, it's twice that size. So it just goes beyond 10 megabytes limit, which is or 16 megabytes limits, which is default.
Oh, so
it seems to not fit that buffer.
Because we're duplicating archiver on the farmer right now. So we have to send the blocks over for it to archive.
It's not that. It's not only that. Like you will not be able to get the block at all from the node using RPC if the block is too big.
Okay.
So I feel like that's what's happening.
Okay, so even though we have a limit on the block production in the mempool, so that the blocks don't exceed like 5 megabytes, whenever they're encoded, they're still larger than what the RPC can handle.
That's my current working idea.
Okay.
And when I increase this message here, it no longer breaks on the node side, but it breaks on the farmer side because I didn't adjust the buffer there. But if you want to get it through the Polkadot.js front-end application, it will break there as well. So I think we need to figure out what to do with it, either to decrease the block size or figure out where the root cause is. But basically, this is like the next problem that we have. Yeah.
What's the current block size limit that we have?
I believe it should be 5 megabytes, but I didn't check. I think Serge checked it. It should be 5 megabytes. But basically, we have a pathological case. Like none of the production chains based on Substrate, I believe, have thousands of transactions in one block, and definitely they are not measured in megabytes. In our case, we are producing like megabytes worth of data in one block during 1 second, which is like ridiculous. So we're just hitting all kinds of edge cases.
These are good. These are all things that we're going to eventually hit when we get into scalability.
Yeah,
so
definitely.
It's good to know about them now.
So I think this just pull request causes significant enough increase of performance such that it hits this problem. So I think we need to figure out how to handle it before we can merge it. Otherwise, it will break too often.
Right. Okay. And what are you thinking right now as a solution?
I just need more time to debug this. Happened like 9 in the morning, and I had to process it.
Okay. Okay, but I mean, it sounds to me like we just need to enforce some block size limit.
We need to debug more where the actual problem is. I'm just saying where the theory is. I cannot like guarantee that that is actually the case. Maybe something slightly different.
Okay. And this, okay, so do you have anything else, Nazar?
I think this is about it.
Okay. So let me try to recap and make sure I understand the problems that we have and the priorities for them. So the first problem is that we are overloading the mempool, and we're running out of memory. Well, we might be overloading the mempool, but we're running out of memory.
We are overloading sometimes.
Sometimes, okay.
Yes.
Sometimes we're overloading the mempool, but we are definitely running out of memory as we overload the mempool, the backlog is filling up on the relayer and it's crashing. So we've got to implement this queue of max in-flight transactions. And that's something that you're working on, Serge. Right? Okay. And then the other and so that's causing it to crash. Then there's a bottleneck. One of the biggest bottlenecks is the signing, which you've implemented this worker pool for. But then once we do that, then we are exceeding we're probably going to overload the mempool there as well. And on top of that, the blocks are getting too big and it's occasionally causing the farmer to crash because the RPC can't handle it.
Yeah, and it's a little bit harder to debug because we have the BK as 100 right now. So farmer will only try to fetch blocks that are too big after like 100 blocks passed. So it's not immediately obvious when the problem happens. It just like later happens.
But you can reduce that big K for testing since there's only one
Yes, I
node
can.
network, right?
Yes.
Yeah. Okay. Okay. And for all of these multiple pull requests you've got out for Polkadot.js, do we have like one branch that we can run locally that already captures all those, or do we have to wait for this to get approved and merged before we can start using it?
The compiled files are actually not included in the repository. It's only in releases. So I think we'll need to wait a little bit. But I think the sign-in on the worker pool should be big enough upgrade to actually be the primary source of improvement.
Okay. All right. Okay. Well, let's look at the board now. Unless there's anything else you guys want to talk about before we discuss next steps.
Should I share it?
I got it. I'm pulling it up.
Okay.
All right. Can you guys see?
Yeah.
Cool. Okay. Extend processing from Genesis to parachains. You said this is in progress right now, Serge?
It's in review. It was in review. We can drag it to complete it.
Oh, it has been completed.
Yeah, currently on the board, it's in review.
Okay. Okay, I must have missed it. That was, sorry. That was, there it is, completed. Cool. So that's been merged and approved.
Right.
Okay. All right. Trying to figure out how to make this work with my computer. Oh, why have I lost the ability to scroll? Shift, Alt. Okay,
Must be
that's really
shift.
annoying.
Shift and scroll.
Nope, shift's not working either.
I think refresh the page, yeah.
Yeah, that's what I'm doing. There we go. Sorry about that. Okay, and oh, come on. What is going on here? All right. Well, if my computer would work, I could definitely use the board. Maybe I could drag. No. Oh, this is really frustrating. Maybe I'll just make it.
Maybe let me share.
Yeah,
Maybe they've
I'll just
deployed some update that broke it.
something happened there. Yeah, I'll let you share, Serge.
Okay. Is the size okay for you?
Yep.
Yep.
Yep, looks good. Okay,
So
in progress.
Yeah, we have transition is in progress. This is the
And
one.
let's talk about that one a little bit more.
Yeah.
What's the status on that one?
No big progress so far. I just started today.
Okay. But you understand, like, implementation wise, what you're going to be doing?
Yeah, we'll reuse same logic we use for resyncing blocks for while we process over the chain. So we will do the same for each chain we have in archive. Once archiving, once processing from archive is done.
Okay. And then we have a ticket for the in-flight transaction pool.
In-flight transaction ticket?
The one that we were talking about earlier, the issue where we're overloading, we're sending too many transactions, we're overloading the mempool, running out of memory on the relayer.
Yeah,
what did you call it?
One. Yeah.
Okay. So I think
let me put it here.
I think that should be higher priority than the transition because we can't even achieve a transition yet, right? Because we're not even able to upload from Genesis.
Yeah, okay, I can tackle this first.
Okay. And then Leo is working on, we'll be working on that.
Yeah, on container.
And that will help you with debugging. Okay. All right, let's just go through the others that say no status. Dynamically get parachains.
Yeah, so currently we have to specify parachains in the JSON file, but yeah, there is a better way. So because we have to manually add new parachains as they arrive on Kusama.
Right.
So in order to just not manually do this, we can dynamically fetch them as we encounter new para IDs in Kusama blocks. So this is what it's about.
Okay, I'm just reading through these. I think we're good. All of these are optimizations. Let's just scroll down and see what else we have after create proxy account. And palette utility to Subspace for batching of transactions. Okay, yeah, this is actually something I was going to ask you guys about, these last two, batching and multi-put. Since signing is such a big bottleneck here, if we do a multi-put, that's just one signature, right? We're not verifying every put.
Exactly. And
Yeah.
actually, the implementation, the way it works, it first hashes the payload if it's too big, if it's bigger than 256 bytes, and then it hashes that one. So we'll basically be able to like concatenate everything into simple hash, and then we'll hash, we'll sign the hash if we can make multiple work.
Yeah, so it seems like that would probably be the next step after we fix these two bugs on the relayer or we implement this like rate limiting of the relayer and investigate the bugs we're having on the substrate side. What is the difference? Are these like the same ticket or the same thing? Or are these different parts of the same problem? These two tickets?
I think it's two options of how to do it.
Oh, those are separate. Yeah, it's more like two options. So this is only for put. So we include multiple blocks in one transaction. And this one is to use a palette utility to send batch of transactions. And we can use it not just for block transactions, for other things as well. Like for creating feeds and transferring balances. So this
Which one do we think will be easier to implement out of those two?
I think it's obvious how multiple call would work. But I think batch transactions should be quite simple as well. But I didn't work with them. So.
And which one do we think will get a better performance improvement out of, or do we know?
I would say for puts, probably multiple call, because in case of batch transactions, we will still have like individual transactions inside of it, but here we'll have just one. So it should be more compact, more efficient.
Okay.
But I think
so let's
sorry.
Go ahead.
Liu-Cheng mentioned before that palette utility may be useful for other things as well, not just batching transactions.
Yeah, I think we need to include it eventually.
No. Okay. I would suggest that we make the put multiple the next highest priority, and then this add palette utility we can put back to the top of no status as the next highest priority after we complete some of these.
Okay.
All right, and so Nazar, on your side for the relayer, you're really just waiting on a lot of PRs to be approved and merged in. There's really no additional work for you to do on that, right?
I will be debugging the issues that we have. those are resolved, you should be able to increase the throughput quite a bit. But we are hitting some walls. We need to figure out what they are.
But that's on the node side, not on the on the substrate
Presumably.
client side. Yeah.
Presumably.
Okay. But I just mean in the relayer, there's really no additional profiling or debugging for you to do at this point.
Not yet. Once I can push more stuff into the node, I will enable profiler again and see what happens there.
Right. Okay. Is there anything critical that you, in the backlog there, Serge, that you see we should revisit?
Not like super critical, but yeah, I've added today a bunch of tickets here. It's mostly like testing and refactoring stuff. This is the one for logs. Probably we will remove it once Leo will implement his ticket on the Docker container. Optimize. Yeah, mostly optimizations and technical debt here.
Okay.
So we can tackle it later.
Okay. So on the, yeah, if you can scroll up to the top there, please. Okay, so so your priority right now, Serge, is to implement this max batch size for relayer sending to the mempool, and then it will be to do the transition from archive to real time, and then it would be to implement put multiple. But I think really only those first two are the most critical ones right now. The third one is really a further optimization or the next level optimization we might get.
I think palette utility doesn't really belong to this board. More like a general protocol board. And probably someone else can also work on it, not just Serge.
So
yeah, actually, that's a great point. Yeah, can you move it to the protocol board, and assign that to Liu-Cheng? Is that something you think you can handle, Liu-Cheng?
Protocol board, this one, right?
Yeah. Can you hear us, Liu-Cheng?
Sorry? So
yeah, we're talking about palette utility.
oh, okay.
And adding that in.
Yeah. That's an easy one.
Yeah, is that something? Yeah, we're going to assign that to you.
Okay, sure.
If you can move it over to in progress for Liu-Cheng. It's on the bottom on the left. There it is. Yep. Can you open that up just to see what the if it has any details right now?
No details.
Okay. But we're not gonna actually use it. We're just gonna add it to our.
We might, but it's like outside of the protocol implementation at that point.
Yeah. Okay. Okay, and can we stay on this board for a sec, Serge?
Sure.
Yeah, actually, if you want to change something, go ahead and edit that.
No.
Okay. All right. Okay, so you're really working on optimizing the seeding. That's the task you're on right now, Nazar. So I think all that's captured in here. Okay. All right.
See the initial history after startup for Serge. Is that already done? Or what was
I would say not until we have this memory leak issue resolved.
Okay.
Not until we can actually get to a full archive being written. Okay. So Serge, are you clear on next steps?
Yeah.
Okay. So it sounds like. Go ahead.
No, I was asking, should we move back to relayer board?
I think we're good on that, unless there's anything else you wanted to cover there.
No.
Okay. So, yeah, I think we're good. Is there anything else you guys want to cover?
No.
All right. Thanks everybody for watching. We'll see you guys next week with more updates.